So we have already looked at three trigonometric functions, sine, cosine, and tangent. However, there are actually 6 trigonometric functions. So let's look at the other 3. So if I were to take a triangle, a right triangle, and we go ahead and identify this angle here, theta, because remember you have to identify one of the acute angles. And once you do this, this is the hypotenuse. That's just HYP. This one's the opposite. And then this is the adjacent. All right, so the 3 trig functions we already have is the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta would be the opposite over the adjacent. Okay, so now these are the 3 main ones. These are the ones we use most of the time. But there are 3 other ones, and so let's introduce those. The first one is the cosecant. All right, now the cosecant we abbreviate as CSC. Right, so this is the cosecant. And the cosecant is going to be the hypotenuse over the opposite. The next one is the secant. And the secant we abbreviate SEC of theta. And this is going to be the hypotenuse over the adjacent. And then the last one is the cotangent. And the cotangent we abbreviate COT. And that's going to be the adjacent over the opposite. All right, so really, if you think about it, if you have an angle here and these 3 sides, really when you think of a combinations of different ratios that you could create, there are 6 possibilities. So this just completes those 6 possibilities. Now, you're not going to have to worry too much about memorizing these. In a video here pretty soon, I'm going to explain how we come up with these, or how we remember the cosecant, secant, and cotangent. But you do need to remember that they exist, and there are some applications for them. Okay, so now we're going to look at circular trigonometry. I guess that I should not be there. Trigonometry. So, up to this point, we've worked in right triangle trigonometry. And that works for a lot of great applications, and we saw a lot of those when we worked with right triangle trigonometry. But there are a lot of applications where we want to work on this concept called circular trigonometry. And so we'll spend a good amount of time and a good number of videos developing this concept of circular trigonometry. But here's the basics of how we start this process. Of course, we need a circle. So there's my circle. And then within this circle, we're going to put in an x and y axis. Now, of course, we're going to put in this x and y axis with the idea that the center of that circle is going to be at the origin. The next thing we're going to do is we're going to put a right triangle within this circle, or inscribed in this circle. And so to do that, we're going to make the hypotenuse go from the origin to a point on the circle. And then the legs, well, one leg is going to be along the x-axis and the other leg is going to be vertical to that. Now, instead of having, and so here's our angle theta, sorry about that. And instead of having opposite, adjacent, and hypotenuse, we're now going to call this x, this y, and this r. Now, hopefully this makes sense logically because, if I have a point here, x, y, well, the length of this leg is the distance x, the length of this leg is the distance y, and then r stands for the radius. Now, one other point about this is that the distance from this point here to this point here is the arc length. And the arc length is s equals r theta. All right. So now that we have this, let's go ahead and write out our trig functions. So the sine of theta, well, sine is usually opposite over hypotenuse, but now the opposite is y, the hypotenuse is r, so it's going to be y over r. The cosine is normally adjacent over hypotenuse. Well, the adjacent is x and the hypotenuse is r, so it's going to be x over r. The tangent is usually opposite over adjacent. So opposite is y, adjacent is x. And so these are our three main trig functions. Now let's get to the other ones. Let's see here. We have the cosecant. Okay, cosecant was hypotenuse over the opposite. So the hypotenuse is r, the opposite is y, so it's going to be r over y. The secant was hypotenuse over adjacent, so hypotenuse is r, adjacent is x. And then the cotangent. The cotangent was adjacent over the opposite, so it's the adjacent is x, the opposite, so it's x over y. Good. All right, there's one other part that we're going to then put in here, and that has to do with the Pythagorean identity. Or not identity, sorry. Pythagorean theorem. Getting ahead of myself. Pythagorean theorem. Now in the past, we would use a squared plus b squared equals c squared. And that's technically correct, but this is something that we use with right triangle trigonometry, and really it's something we use in, say, geometry, algebra 2, things like that. So we're no longer going to use that. We're going to kind of X that out. We're going to look at our right triangle here. Now the legs are x and y, and the hypotenuse is r. So our Pythagorean theorem is going to be x squared plus y squared equals r squared. So from this point forward, especially when you're working with math that's at the trigonometry level and above, really we should be using x squared plus y squared equals r squared. And then if you're helping someone who's in, say, geometry or algebra 2, then of course you use a squared plus b squared equals c squared. But we'll focus on x squared plus y squared equals r squared. Okay, so let's look at an example here. And let's find the values of the 6 trigonometric functions of theta. And this problem comes with a figure. So here is our right triangle. There's theta. This is 4 and this is 2. Okay, so let's go ahead and go through our 6 trig functions. The sine of theta. Well, the sine is the opposite over the hypotenuse, or the y over r. So that's 2 over 4, or 1/2. The cosine of theta is the adjacent over the hypotenuse. And we don't have the adjacent, so we're going to go ahead and use a trig identity to get that. Or not a trig identity, to use the Pythagorean theorem to get that. I keep on saying that. So we have x squared plus y squared equals r squared. So this would be x squared plus 2 squared equals 4 squared. So that's x squared plus 4 equals 16. So x squared equals 12. And when we take the square root of both sides, x equals plus or minus, in this case it's 2 times the square root of 3. Now we do have to figure out if we use plus or minus. For right now, until we get further on in trigonometry, we'll just assume that we're going to use the plus. But there will be times later on when we do have to use the negative. Okay, so now the cosine of theta is 2 times the square root of 3 over 4, which is the square root of 3 over 2. The tangent of theta is the opposite over the adjacent, or y over x, and so that's 2 over 2 square root of 3. Which is 1 over the square root of 3. And of course we need to rationalize the denominator, so that ends up being the square root of 3 over 3. Appears I might need, let me see if I can use a sheet of paper here. Right, so the next one we need is the cosecant. Right, cosecant, if we go back up here, is r over y. So that's 4 over 2, which is 2. The secant is r over x, which is 4 over 2 square root of 3. So that's going to be 2 over the square root of 3. And we got to rationalize the denominator, so it's 2 square root of 3 over 3. And then the cotangent of theta is x over y, so that's going to be 2 over times the square root of 3 over 2, which is the square root of 3. All right. Now the last thing we're going to do is we're going to put it all together. So the sine of theta is 1/2. The cosine of theta is the square root of 3 over 2. The tangent of theta is the square root of 3 over 3. The cosecant of theta is 2. The secant of theta is 2 square root of 3 over 3. And the cotangent of theta is the square root of 3. And then we put a nice box around that. So when you do these problems at the end, always rewrite, because here we have a bunch of work, but we want to rewrite it so it's easier to look at. And that gives you your final answer.